Okay, so one of the type of proofs you're going to see is filling the missing statement and reason. So you have to fill in the missing step that they have in this proof. So it's all put together for you except for that step. So we are given that BC is parallel to AD. So BC is parallel to AD, all right? We are also given that segment BC is congruent to segment AD. So there's a pair of congruent sides, right? We need to prove that angle BAC, so this angle right here, is congruent to angle DCA, this angle up here. That's what we're trying to prove, okay? So obviously, right, we need to prove that this triangle is congruent to that triangle, and that's what they do right here, right? So we're missing one step. So let's see if we can kind of follow this through. Now, it kind of stinks because it's the next step. So let's go through the rest of the proof and see what they've done. So they said that AC is congruent to itself, okay? And now they say the two triangles are congruent by side, angle, side. So this would be a pair of sides. So where would the angle have to be for it to be side, angle, side? Well, if this is my side and this is my side, the angle in between them would have to be this angle right here. I'll put. So that angle would have to be congruent. And again, same thing here, side, side, so this angle. So the question is, are those angles congruent? Well, watch. We haven't really used the parallel lines yet. Remember, parallel lines don't mean congruent sides. Parallel lines typically mean congruent angles. Well, look here, let me trace this. Let me trace this parallel line, and let's use AC as the transversal. And do you see the Z? Remember that in the Z, you create alternate interior angles, and those are congruent. So we can say that angle BCA is congruent to angle DAC because they are alternate interior angles. So I'm going to say two congruent angles, and I said angle BCA down along the parallel side is congruent to DAC down along the parallel side, and I'm looking for parallel lines and alternate interior angles. Parallel lines, congruent, alternate interior angles. That's what I think the missing step is. Because then, for reflexive property, that's side, angle, side, and once I prove the triangle is congruent, then yes, those two angles are congruent because they are corresponding parts of the congruent triangles, and they will be congruent. I'm sure I want to submit. Oh yeah, and there I go. All right, next problem coming. Okay, so the next kind of problem I have here is a reasons only. So now they're going to keep feeding you the statements. You just have to go through their list of reasons and see if you know what's going on. So let's see if we can kind of piece this together first. So we're given some congruent sides, right? So we're given segment AB is congruent to AC. We're given segment DC is congruent to DB. We want to prove this, that segment AD bisects angle BAC. This is angle BAC. For something to be bisected, you have to split it into two congruent parts. Angle BAC is the thing being bisected. So that means that angle 1 here and angle 2 there, they must be congruent. If they are congruent, then that means that DA does bisect angle BAC. So that means we have to prove that triangle 1 and triangle 2 are congruent triangles, because then we can use CPCTC for these two angles and then say that that segment AD bisects angle BAC. I know it's a lot. I'm talking a lot, but I like to plan things out. I'm a planner, right? I'm a planner. So the next thing they have for us is that segment AD is congruent to itself. So that would be this side here. I'm going to put 3 dashes. So of course that's reflexive property. So we should know that whether we had to do it or not. Okay. And now they're going to say the two triangles are congruent. Why? Well, if we look, we have side, side, side. This is SSS congruence. I think it says side, side, side. Yep. And now, because the triangles are congruent, we can say that corresponding parts are congruent. So again, this angle BAD is a corresponding part to this angle CAD. You can use the triangle BAD, CAD. They're corresponding parts of congruent triangles. They're congruent. CP, CTC. And now once you say those two angles are congruent, that does mean that this segment DA is bisecting angle BAC because it splits into two congruent parts. And I'm sure it's going to say something about being an angle bisector, splitting into two congruent angles, something like that. Let me erase this so you can see what the choices actually say. So we picked the right one. So a segment that divides a larger angle into two congruent angles bisects the larger angle. That's it. Perfect. The proof is complete. You may now press submit. Oh yeah. Okay. I'm going to make another video with a couple more proofs.